All right.
Say something.
All right.
Just something.
Are we good? All right. Cool. Okay. So I'm not going to do an introduction. I don't give a fuck who started the show. What?
This is that.
All right. Cool. So basically, I just managed to draw a dot in the middle of the screen. Not the middle, but yeah, in the screen. And so what I want to do now is make the dot fall. Right. All right. So I think for that we kind of need like velocity and shit. Um. God damn it. So let's try and implement velocity. Oh, sorry, vector rather. I think vector is vector 2D. We need the x and y components. I test 2, y, I test 2. So for the player, we're going to add velocity. It's going to be a vector 2. Vector 2D. Yep. So the compiler is already complaining right here that we need to add velocity. I'm going to implement something right here to just create a new player. We just need the position. So what this function will just do is just create a new initial level player. That's all. It's not like anything crazy. So we just need to pass in the position point 2D and then return self. Position is going to be point 2D. Just passing the position. Yeah, this is shorthand. Yeah. For the velocity, let me implement something cool. Vector 2D. We could just create a zero vector. Just returns a vector. So then no, the zero vector is just x and y 0. Something is off. Okay, okay. I think what's happening is because of this guy right here. Vector 2D 0. Y 0. So yeah, so we'll create a player in that position and then would set the velocity to 0. Then right here, we can just come here and do cut this off. Player new passing position. Yep. So now, like I said, I want to shoot 4. We have our vector of velocity right here. We're going to implement something new. I'll just name it compute or processing, whatever. I'm taking a mutable self. And then what we just want to do here is like let the position, the point fall. So we're just gonna decrease the or increase the y values right here. So something called self-dot position dot y. We're going to add, let's say 1. That's basically it. If I want to shoot a 4. I'm going to put this at the top of the screen so we get a better view. Set that to 0. And then I'm going to call compute right here just before we draw. Compute. Okay, let's run and see what's up. Fuck. Yeah, it falls. It falls, yeah. Falls, but we get some error. Dead code, blah, 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 blah. We'll get there. Let me set this to 0.1. Oh, it's not position is an integer, not a float. Well, I'm just gonna tell the fuck here and do that. I will have an issue here because this guy is an integer. Yeah, which is weird. Well, what to do? I'll convert this to items too. Oh, I see. The same as this guy. Just cross that shit right there. But then, let's run this and see what's up. I still have that error. Oh, it has to be a float. 0, 0. Alright, cool. Nice. See those falls down. I'll make the square a bit bigger. Nice. Now what I want to do here is use velocity to, so if you take a look at this, the box is falling down to constant. Let's say.
Why is it slowing down?
I think it's my CPU, like CPU. Oh. My PC is kind of hanging. My PC was probably hanging. Right there. Let's see it again. Yeah, I think that was smooth. So what I was doing now is let the velocity increase as it falls. So instead of adding to the this guy right here, what I'm going to do is add to the velocity. I'll say velocity. No, I just realized 0.2D is actually just a vector. See?
Yeah.
So we could just even scrap this guy out right here. This 0.2D. And just use vector 2D. So the position is going to be vector 2D. That vector is just, we'll convert this to a float. Here, 0.0. Okay, looks like we're good. So instead of just increasing the position, what we're going to do is we increase the velocity. So the velocity just accumulates over time. And then we just add the accumulation to the position right here. Y plus equals, so let's see the Y. So let's see what's up. Oh fuck, that was fast. I'll drop this down 0.01. I think the reason why that was fast is because we don't have any frame rates. Like it's moving like, let's say, around like 500 plus frames per second. So what I want to do here is reduce that shit I mean, this is not a very nice way to reduce frame rates, but uh, it's not really a nice way to reduce frame rates, but you can just work with this. So we'll use the sleep function from the thread. We'll pass in the duration from which one here? So 0 seconds and then 1 nanosecond over 60. That's probably like 60 FPS. So I think so 0.3. If we run that same value, get something slower, yeah. Cool. So I'll just reduce this a bit. And we'll see how this goes. Hard to tell if it actually falls faster. Well, 0.3. Just check it out again. Yeah, that one's quite visible. You see when it gets down, it just falls. Yeah. Not bad. Alright. Now, we're able to draw a rectangle to the screen and all. And what I want to do is put a wall, like a platform right there. So then when it gets there, it just hits it and bounce. Yeah. Sure, let's check it out. So let's implement a wall. Let's create a structure first. Wall. So now this wall is a static body in the sense that it's just there, it doesn't move, but then it can cause, like when something interacts with it affects the physics of the other objects. So basically we need a position to put the wall. Position is vector 2D. We need the width of the wall. Width is going to be an unsigned integer. Unsigned 32-bit value. And then we need the height. Also an unsigned 32-bit value. Alright, so now let's create a new wall. So I'm going to put it just below the ball, when the ball falls. So looking at the position right here, the ball should be, the X should be around, let's say, let me just put X on like.
I think you wrote ball. So
it is wall. Yeah. Alright, W. So we'll put the X at 100, put the Y at 300. My bad. Alright, why is this red? Oh, we're missing the width. And so the width is going to be let's see the width. Okay, this is the X, Y, god damn. X is going to be at this X right here. So X is going to be at, let's say, 10. And Y is going to be at, let's say, 600. Or like this 0 here, then down. 0 up here, then down is like the end. Like probably like 0 to 1. Like it increases as it goes down.
Yeah.
So I'm going to set Y here to, let's say, 700. And the width of the wall should be like, let's say, the width of the wall should be, let's say, 300. Then the height of the wall should be, let's say, 50. It's just gonna be like a rectangle, yeah. So now we have the wall. If we run this, we're not gonna see anything. I mean, we just put the code in the table. We're not drawing. We're not drawing shit, yeah. So I'm just gonna copy this because it's almost the same. Just draw right here. I mean, I could use straight, but I actually don't know Rust that well. So we're just gonna implement wall. So now we have a wall that we can draw to. I can draw a wall on the canvas. And we say self the position, the Y, blah blah blah, blah blah. What's gonna happen is that we're going to call the canvas draw right here, the wall draw, that wall dot draw, and that will draw on that canvas. So why is this? We cannot mute it. Like I said, by default, you can't actually mute it in a variable until you like specify explicitly that you want to mute the shape. So yeah, let's see. So now we need to draw the wall well. I'm going to draw the wall with green or blue rather. It was going to be blue, so 255. So we need to draw with the actual width and the actual height. And this, unlike the ball, I want to draw the top left. Like this is the position of the wall. You know, unlike the player, the position was at the center. This position of the player. Well, here, this is the position of the wall for me. So I'm just gonna say X is the actual X, and Y is the actual Y. And the width is the niggas will self the width, height, self the height. So if we run this, but now it does actually bounce because it's just drawing. Like no physics, no nothing. So now how do we actually do physics, you know? So now let's go back to the compute.
How does that compute?
It calculates the position. Right here we see velocity of y, so it increases the velocity by 0.3 and then adds that velocity to the position. Alright? So now what I want to do is that here, while we are computing this guy, I want to check if we hit the wall. If we hit the wall, then we bounce. No. So just because I'm lazy, I'm just going to pass the wall here. So I'm just going to pass reference to the wall. Let's say wall. Reference to the wall. Right here. And here we'll pass the wall. There's the reference to the wall. So one more thing. I want to let me leave that. Okay, now we have the wall. Now let's work with the wall. We now have a reference to that wall. Like we have a pointer to where the wall is stored in memory. So now increasing the velocity y and the position y. I want to check if the position is where the let me turn this off so we can just visualize it. So now this is the ball. So when the position of the ball gets to this point, we want to reverse the direction of the ball. Huh? That's how we set the bounce. So we first need to check for collision. So I think rect should
be when
when two overlap. Yeah. So I don't know if there's a collision function in rect here, unlike Pygame. So I'm just gonna check. Let's see. Shit, my bad. Oh, I could just check this. So this is the SDL rect. This is the rect function here. From center, blah 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 blah. Set speed, set height. L shifted, R shifted. I could just use this guy. Okay, we can actually check if a rect contains a point. We can use that to check for collision. A rect is a number of coordinates that forms a rectangle. This. So if a point enters here, which is another coordinate, we cannot tell. But just to be on a very basic side, I think let's just implement collision by ourselves. All right. So I'm going to write a function up here that checks for collision. And so just return a boolean if it actually finds, like if it actually collides. So it's going to take two values. Okay, so we're going to take two values, the first rectangle and the second rectangle. What?
Okay, yeah, the first rectangle, which is guy.
Yeah, the second rectangle. So the rectangle is just going to be rect A. Rect A and rect B. Okay, so now, how do we actually know when one rect has collided with another rect? How do we know when one rect has collided with another rect?
As in contact another.
Collided. If any point of the rect is of one rect.
Is there a way you can track, like you can track every point as it drops?
We already have the position. So we'll first need to check if this rect, if the position of this rect is in the other one.
No, see, do it for when it has gone into the inside, like then we'll just truncate from there. It doesn't have to be exactly. You get what I mean?
Yeah, I kind of do. So let me write one function first. I think this one will actually be a stepping stone. So what this one is going to do, we want to check if a point is inside a rectangle. Now what does that mean? We have a section of coordinates here, like let's say this here is 1 and this one here is 5. The middle is going to be 2.5. The middle is going to be 2.5. So the points here, let's say there's a point here at 2. If that point is greater than or equal to 2.5, you know, as 2, the point is here, the rectangle starts from 2.5. The point is at 2. I think I should do the drawing. Shit, no, not you. So, like this. So, there's a point here. This is 0, 2, 2.5, 5. So the rectangle is right here, right? So the rectangle starts from 2.5 and ends at 5, but the ball is at 2. So now, how do we know that this ball has collided with this rectangle? If the y position, if the y coordinate is here at 2.5, if the ball is here, that means we've collided anywhere between 2.5 to 5. That means we've collided with this guy. Yeah. Mind you, the x, it also needs to be at the x coordinate, because if the ball is here, we've not collided. So if this is true, that means the y is in this range and the x is in this range, and we've collided with the rectangle. So I'm just going to do that right here. So points in rect. I'm going to take a point. My point is going to be vector 2D. I think I should move this down. So create a point vector 2D, and then we'll create our rect. There's going to be references on the actual value. So what I want to do here is to check for the x and the y. If let's say let's x in range. X in range is going to be points dot x. I don't know if in is a thing. Let me search. Let me just be basic. I'm not doing any raw specification and again. So if point x is greater than rect dot top, as the top of the rect. If point x is greater than or equal to rect dot top, then that means no top, like yeah, my bad. Left and point x is less than or equal to rect dot right. So that means okay, I missed after I was writing Python. So that would mean here as if x is greater than or equal to this part of x here of this rect, or is less than, greater than would be like towards this direction, from here towards this direction. This is greater than, from here towards this direction is greater than. While this is the right. If the x is less than this or equals to this direction, that means from here towards this direction. That would mean if the position is inside this range of x values, and it has collided with this guy on the x coordinate. So if this is true, let's see why this is written up. Mismatch types. Let's convert this to an I32. And this one to I32. So we also need to check for y. Let's y in range would be y is greater than top and y is less than bottom. So what we do here is just return that both of them are true. X in range and y in range. Okay, so now you can just check if a single point is inside the rectangle. So we can use this function here in our player compute function. So if point in rect point is going to be reference to our vector 2D. That'll be the position. And the rect here is going to be the wall's rect. And does the wall have a rect? No. So let's try and create one. So I'm just going to return a new rectangle. Just the same as this guy. So we're just going to close this and return this here. Okay, so now the wall has a rect, so we can just do wall, the rect. So now, if they actually do collide, let's just reverse the y component of our velocity. Guess, yeah. Or
But
the,
then you have to draw this thing in memory.
no, like after,
Drafting it. I know you mean, but
like all these things happen in memory. Yeah.
Not,
So now, what do we do? Flip the position.
you want it to well, then that would mean we are setting up we are reversing. What I mean, do you want it to be like dynamic, based on?
It is dynamic.
It is dynamic naturally. Okay. Well, it's not really dynamic if you just drop it down every time. Like,
Drop it down how?
when you open it now, you run it now, it drops down the same way every single time.
Okay, you want like it's one at a time.
It's not.
What we are doing now is just checking if it falls from up, down. Just want it to bounce. So I think what we're going to do here is probably reverse the velocity of the position. Multiply the velocity by -1. I don't know if this is the thing in Rust. Oh, my bad. The y to the y component. One zero. Okay. Let's just what's up. Fuck. Yeah. Hmm? A lot of things actually. Let's see. No, I don't think that's. Why am I getting this wrong? So flip the direction of the. Okay. Oh, not. God damn it. Oh, okay. I know what to do. No, I do not. God damn it. Unless implement something static. What's crazy is that I easily implement this in Python. When I write Python, I just feel the thing just flow. But I mean, I know it's the same logic, right? But I just feel this shit. Let me see. Okay. What happens here is that when we flip this guy, expanded by minus, it doesn't really. Let me do something really basic first. Right. No, do that. This should actually work. Let's see if this even
What are you trying?
like let's see if this part even triggers. Okay, the if statement does not even trigger. I mean, there's a problem with our function right there. I'm trying to print x in range and y in range. So we get shows a false, but at some point it's true. Oh shit! I did. I made a mistake in the function. It's supposed to be x here. It's supposed to be y. Let's try this and see what's up. Ah, check it out.
Oh, cool.
Nice. I just
What
made.
happened?
I wrote instead of point dot x here, I wrote point dot y. Yeah.
Cool.
All
Yeah,
right.
nice,
So what I want to do now
man.
is,
That's interesting.
if you check it out right here,
Yeah,
it just keeps bouncing,
yeah.
like
No
bounce,
direction change.
bounce. No, that's direction change right there. But then it's supposed to dampen, like energy is supposed to deplete over time. Yeah.
Yeah,
So we need a way to dampen the how do I put it? We need a way to dampen the velocity whenever it hits.
yes.
You know when you put a button for it, bounce goes up a bit, then
And
before you know it
keeps
dies down.
going down,
Yeah.
until it goes down finally.
But it looks like this one is doing it.
Yeah, it's doing it already. Yeah.
But it's is it that it's too
No,
slow?
wait,
So
it's sequential. Yeah, it's working. Mad.
I think with this model, after a while, it's going to sink through the wall. I'm not sure the
Let's see,
wall.
let's see.
And that's crazy.
Sweet Betty goes to the wall.
Yeah,
I say it doesn't.
that's what's up.
Uh, uh, it doesn't. Does it come out though?
No, it just goes down. And there's a reason why that happens is because the we are checking the position at the center of the ball. So when the ball is at the center, it tries to go back up. But when it goes up, you're still in the wall. So you go up, you go down, you go up, you go down. Eventually, it does go right through. But hey, I mean, it works, I guess. I know what's crazy. We didn't actually implement any damping
Yeah,
function.
it just did it by itself.
No, that's not supposed to happen. I mean, it's not like it's AI or anything. I know what's crazy. I'm actually not going to look into it for now. Maybe next time when I stream again. Yeah. But yeah, but I think I've made like some kind of progress, I guess. First time implementing this in Rust, so um, I mean Rust is weird. the whole thing is just hard to work with, especially when you come from Python. Um, but yeah, all right. What do I do?